The way we suggested in the last video for the telescope example, namely keeping the CCD temperature fixed while varying the outside temperature, is a difficult task to perform. Indeed, in many scenarios, such an ideal experiment may be just infeasible. For instance, age of salesmen is often found to have a positive correlation with their monthly sales. A natural suspicion is that age influences sales only through experience. That is, older salesmen are usually the more experienced ones, and that is why they can sell more. Here, we cannot just grab a salesman, hold his experience level fixed, and artificially vary his age to see the effect on the sales. Statisticians have found a way to answer the question without doing any such experiment. Here is the general setup. We have two variables x and y, and we have a third variable z. We want to know if the correlation between x and y is only through z, or there is some alternative route between x and y. We first cast this somewhat vaguely worded problem to a concrete mathematical form. Here, x, y, and z are jointly distributed random variables. If the correlation between x and y is only through z, that means holding z artificially fixed should sever all connections between x and y. More mathematically, if I consider the conditional distribution of x and y given z, the correlation computed from this conditional distribution should be 0. Correlation of xy given z, that should be 0. If it is non-zero, that would indicate some alternative route between x and y which is not through z. This correlation computed based on the conditional distribution is called, quite naturally, the conditional correlation between x and y given z. Of course, you may have more conditioning variables like z, w, u, v, whatever. Accordingly, we can have conditional correlation between x and y given z, w, u, v, etc., etc. Conditional correlation is a nice mathematical definition of a somewhat nebulous concept. However, it is rather hard to compute even theoretically. Only for very simple joint distributions of x, y, and z you will be able to compute it explicitly. Also, in a real-life statistical problem, you will not have the joint distribution given to you. You will only have data, that is, a list of values of the variables. There does not seem to be any simple way to estimate conditional correlation based on data. So we introduce one level of approximation and define a simpler form of correlation. Here we take x and linearly regress x on z, and then keep only the residual. This residual may be thought of as whatever remains in x after taking out the effect of z. Now do the same thing with y. That is, regress it on z and keep only the residual. So now you have two residual variables. You have to now find the correlation between these two residuals. You see, we are sort of thinking along the same line as for conditional correlation, but the actual steps are quite different. So, this is not really a way to estimate conditional correlation. It is a different but related concept. It is called partial correlation. It is something that you can compute both theoretically if you know the joint distribution and also from data. Unlike conditional correlation, which is of limited theoretical interest, partial correlation is widely used and has a standard notation. If you compute it theoretically, that is from the joint distribution, then you denote it like rho subscript xy dot z. If there are more conditioning variables, z, w, etc., then you list all of them after the dot like this xy dot, z, w, etc., etc. There will always be exactly two variables before the dot and a list of variables after the dot. If the list after the dot is empty, then we get back our usual correlation. If we are computing partial correlation based on data, then we use the letter R in place of rho, like R, xy dot, whatever, zw. The orders of the variables before the dot and also after the dot are not of any importance. But just make sure that no variable appears on both sides of the dot like rho xy dot x. X appears on both sides. That is not allowed. In the next video, we shall discuss more about partial correlation.